You know, right this second, there's something totally invisible happening all around you. Your phone is pulling in data from electromagnetic waves. The Earth is swinging around the sun with absolutely nothing connecting them. A magnet can literally make a paperclip jump across a table. We can calculate all these things, sure, but how do they actually work? That's where things get really interesting.
I mean, seriously, think about that question. It's a question that haunted the greatest minds in physics for hundreds of years. How does an influence just cross empty space? The answer they found didn't just explain how magnets work. It turned our whole idea of reality completely upside down, and it all started with one of the biggest unsolved mysteries in science.
And that brings us right to our first section and to the man himself, Isaac Newton. Now, this is the guy who gave us the mathematical laws of gravity, but even he was deeply, deeply troubled by the how of it all.
Think about it, right? Pushing a book is, well, it's obvious. Your hand touches it, you apply force, it moves. Makes perfect sense. But a magnet pulling iron filings? Or the sun holding the entire Earth in its orbit from 93 million miles away? There's no contact. There's just space. So what in the world is crossing that gap? Newton's own words on the subject are just incredible. I feign no hypothesis. Basically, he was saying, look, I can give you the equations that predict exactly where a planet will be, but I have absolutely no idea how the sun is actually doing the pulling. It's a huge reminder that being able to calculate something isn't the same as truly understanding it.
So, to solve this puzzle, scientists had to do something radical. They had to completely throw out their old ideas and rethink what empty space even means. Because, as it turns out, it's not empty at all. And the big idea they came up with was the field. Now, a field isn't a substance. It's not some kind of stuff in space. It's a property of space itself. Think of it like a weather map for temperature. At every single point in a room, there's a temperature value, right? Even if there isn't a thermometer right there. A field is just like that, but for forces.
So, the old way of thinking was this strange, spooky action at a distance. It's like the sun just reaches out with an invisible hand across the void and grabs the Earth. It's a simple picture, but it explains absolutely nothing about the mechanism.
But the new idea, the field idea, oh, it's so much more elegant. The sun doesn't reach out and pull anything. What it does is its immense mass actually changes, it warps the very fabric of space all around it, creating what we call a gravitational field.
And here's the kicker. The Earth isn't responding to the sun way over there. No, it's only responding to the state of the gravitational field right where it is. The interaction is totally local. The Earth just feels the curved space in its immediate neighborhood and follows that path. And this has a massive consequence. It means if the sun were to just vanish, poof, gone, the Earth wouldn't instantly fly off into space. The change in the gravitational field, that disturbance, would have to travel outwards, just like ripples on a pond, and it would travel at a very specific finite speed, the speed of light. All action is local.
Okay, so at first you might be thinking, this field idea sounds like a clever bit of math, a convenient way to do the calculations. But it didn't take long for experiments to show that these fields were very, very real.
And this became the absolute critical question for a whole generation of physicists. Was this field thing just a new way to organize the math on the page? Or was space itself a real, physical, active player in the universe?
Well, the evidence just started piling up and became totally undeniable. Scientists showed that fields could carry energy, they could carry momentum, they could oscillate and vibrate. And then came the absolute knockout punch: light. The very thing we see with our eyes was discovered to be nothing more than a traveling wave, a vibration in the electromagnetic field. The field wasn't just a concept, it was a physical thing.
Now, for a while, people tried to imagine that fields were made of some invisible substance they called the ether, kind of like how sound waves are vibrations of air. But every experiment to find this ether failed, and it led to an even stranger conclusion. A field doesn't need to be made of anything. It's a fundamental part of reality, all by itself.
And once you accept that fields are fundamental, well, that's when things get really weird. This idea leads to probably the most profound shift in perspective in all of modern physics. It completely flips our idea of what matter even is.
Seriously, this slide right here flips our intuition completely on its head. We all grow up thinking that tiny little particles, like electrons, are the fundamental building blocks of the universe, and they just happen to have these fields around them. But the modern physics view is the exact opposite. The fields are the fundamental reality,
and particles are just what happens when those fields get excited.
Think of it this way. Imagine a huge, perfectly calm pond. That water is the field existing everywhere. Now imagine a sharp, localized ripple moving across the surface. That ripple is what we would perceive as a particle. See, it's not a separate thing moving through the water. It's a behavior of the water itself. A photon isn't a tiny speck. It's a localized vibration, a little packet of energy in the electromagnetic field.
So what this means is that the universe is just simmering with all these different fields, an electron field, a quark field, a Higgs field, you name it. And what we call empty space or a vacuum, that's just all of these fields resting in their quietest, lowest energy state. And if you pump enough energy into one spot, you can literally create a particle out of nothing, an excitation in the field.
Okay, so let's put all the pieces together. When we do, we get a completely new and frankly a much more beautiful picture of the universe we live in.
That old mechanical view of the universe, as a giant clockwork machine made of tiny billiard balls bouncing around, you can just throw that out. Instead, reality is much more like a set of continuous, interacting fields that fill all of space. The universe isn't really made of things. It's a dynamic system that's governed by a set of rules.
And the ultimate expression of this field concept is gravity itself. It's not a force in the way we usually think about it. It's just the geometry, the shape of the space-time field. The great physicist John Wheeler put it perfectly. Mass tells space-time how to curve, and curved space-time tells mass how to move. The stage itself is one of the actors.
So we're left with this pretty mind-bending thought. That magnet pulling a paperclip, the Earth orbiting the sun, they're not some spooky action at a distance. They're just local interactions with a universe-spanning field. We started with a simple question, and we ended up basically dissolving the idea of solid objects. Because if particles are just patterns, just localized behaviors of these invisible fields, then what does that make you or me or the very device you're watching this on? What even is a thing in a universe that's not made of pieces, but of pure potential?
Thank you for watching my video. Please subscribe.